this is Madri Lokesh of JNTU GVUCU. Today we will be seeing about quicksort mechanism. Quicksort is an efficient sorting algorithm that works by selecting a pivot element from an array and rearranging the other elements so that the smaller than the pivot come before it and those larger come after. This process is repeated for the subarrays on either side of the pivot until the array is sorted. It's known for being fast and requiring less memory since it sorts the array in place. But in the worst case, it can be slower if the pivot choice is poor. Despite this, it is commonly used for large data sets due to its average time complexity of big O of n log n. Let's see key concepts of the quicksort. Divide, conquer, and pivot elements are the key concepts. The algorithm splits the array into small subarrays, sorts the subarrays, and then comments the results. Quick sort uses a pivot elements to partition the array into two smaller subarrays, one where all elements are smaller than the pivot and other than greater. The pivot is placed in its correct position and the process is repeated for two subarrays. Let's go through the steps of the quicksort. Step 1 is choosing a pivot element from the array. This can be done in various ways such as selecting the first element, last element, or random element. Step 2 is partition the array into two subarrays, one with element smaller than the pivot and other greater than the pivot. Recursively apply quicksort to the two subarrays until the subarrays are size of 1. The sorted subarrays are then combined, but since each subarray is already sorted, no further merging is required. The pros of the quicksort are very efficient for large dataset in-place sorting, which means it doesn't require additional memory for another array. Often faster in practice than other algorithms like mergesort, and despite having the same average time complexity. Its cons are it is not being stable. Pseudocode for the quicksort. Let's go through the explanation of the pseudocode. Quicksort is a divide and conquer algorithm. It partitions the array into two subarrays around a pivot element. Elements smaller than the pivot are placed to the left and elements greater than the pivot are placed to the right. It recursively applies the partitioning process to subarrays until the entire array is sorted. The above image is the image that is required, and explanation for this is given below. To sort the given array using quicksort, we begin by selecting 14 as the pivot, and then we apply the quicksort algorithm until the subarrays are in the size of 1. After merging, we get the required sorted array. Thank you for learning about the quicksort mechanism.